Hello, my name is Sam McLennan, and the title of this research is Extracting and Communicating Underlying Pseudo-Formalised Procedural Rules in Heritage Architecture, the Case for New Zealand's 19th Century Timber Churches. And so what this research looks at is the use of new digital technologies within the field of digital architectural heritage. Throughout history, there have been many important pieces of architecture that have come and gone. So the question for conservationists is, how do we preserve these cultural artifacts for future generations? Historically, this has been achieved through methods of written description and illustration. However, with the digital age, advancements in modeling software and laser scanning technology allows for complex 3D models to provide analysis as well as physical observation. And so some key examples of these complex 3D models can be seen in Rome Reborn and the Sagrada Familia reconstruction efforts. And so these are early examples using early CAD softwares to develop a static geometry. And so I say that because in more recent examples, procedural modeling has been used. And so what procedural modeling is the creation of a system that outputs geometry rather than just creating the geometry itself. And so what this lends itself towards is the creation of a high number of different buildings that all conform to the same sort of rule set. And so this has also been explored in the film and game industry with projects being of higher detail than that seen previously. And so what this research attempts to do is to build on these precedents by using the method of procedural modeling and seeing how that can be used to enhance the understanding of architectural heritage. And so to achieve this, I've set two objectives, with one of those objectives being to create a procedural model that generates buildings of a specific architectural style, as well as exploring how this method can also be used to investigate lost architectural heritage. To do this, I needed a case study, and what really caught my eye was Wellington's churches. And so, being fascinated with them, I plotted all the churches I could research onto a timeline and found that between the years 1840 and 1900, all of them were built in timber and almost all of them were in the Gothic style. Being a British colony, it makes sense that these timber Gothic structures reflected the styles present back in Britain. And in Britain in the 19th century, the Gothic revival was very prominent. However, the scale and materiality of these buildings differed greatly from one another. With Britain having colonies in many different places, Gothic structures started appearing across the world. One of the key differences, however, between these structures and those built in New Zealand is the use of timber. In the middle of the 19th century, good quality stone was hard to come by in New Zealand, and so timber was used in its place. This was an issue with some religious scholars at the time, with an article in 1845 stating that these are not good models of construction. This is somewhat due to the use of the pointed arch motif, and in stone construction it is a structural form, whereas in timber construction it is more just for aesthetics and kind of structurally redundant. However, perhaps realizing the inevitability of these structures, a few years later the material was venerated for its use in construction of churches, citing the very first spiritual church, that the ark was made of gopher wood. And so this leads on to churches built in Wellington in 1840, and so these were simple timber structures and predominantly Gothic. And so this continued until 1865, when the government moved to Wellington. This brought more money and more people for larger churches, and so these were still built in timber, as no good quality stone could still be found. And this continued up until the 1900s, as Portland cement was being produced in the North Island, and concrete and brick churches could be made. And so this is my case study group. These are the churches that my procedural model will attempt to generate. And from our historical research, we can see that there are no formal rules for these churches, with each of them being a bespoke design. However, it can be seen here that there are many visual similarities, and what this research will attempt to do is create a methodology to try and extract those similarities and define them exactly. Being made of timber, many of these examples do not survive till today. When choosing a place to start off with for this research, I intended to choose a still existing example, as reconstructing it would be much simpler. However, initially this research started off as just an exploration of one lost design, that being St Mary's Cathedral, and so this actually was the beginning of this research. And so what I then did was to gather as much information as I could, and I found a host of photos and, more importantly, an article giving the basic dimensions of the church when it was opened again in 1867. What I then began to do was to break the church down in order to simplify it, and so here I've broken it down into its constituent main areas. Then from the article I could then rebuild these components within the software Houdini, and so this is a procedural software much like the last examples I mentioned before. And so I then began reconstructing these pieces, and then I would compare the reconstruction with photographic evidence. And so what I also began to do was to further break down these main areas into additive and subtractive components. And so a key additive component, an example of that is the buttressing. And so this is what I reconstructed next. So these were mentioned in the article giving basic dimensions, and I then wanted to reconstruct them using a procedural component, so an adjustable component that could be changed in order to create the different designs of buttresses within St Mary's. The next detail area was the rosette window, and so these were the main photos used for its reconstruction. Reflecting on how Gothic geometry is created, it was just a matter of figuring out how to create this shape using just circles and lines. And so once I had the basic shape, I then could extrude profiles along the lines to create the three-dimensional form. And so once I had the three-dimensional form, I could then size it accordingly, and because there were no measurements of the window, I did this via analyzing the proportions of the window to the known width of the nave. The extruded profiles at this stage are speculated, as no photos revealed what they actually were. And so these are just placeholders, and the thing about procedural modeling is that these can be changed simply later on. What also helped to create these speculative profiles was looking at still existing examples and archival data. The next detail area was the parapets, and so looking closer I could see that the quatrefoil pattern was used, and so once I knew that, I then extruded a profile along the edges with the parapet detail and then punched the quatrefoil pattern into it. And so from the photos I couldn't gauge exactly how this parapet was constructed. I looked at similar examples, and there's one still existing of St Peter's. However, that isn't quite the same design, and there's also a similar parapet design in the Wesleyan Church of Manor Street. However, I could not find good photographic evidence of this. The windows were done much the same way as the rosette window, being just pointed arches. The sizes of these windows were also done proportionally, much like the rosette window. And so these are the various window designs present in St Mary's, and they all use speculative window profiles that can be replaced later. And so the final touches was the additions of the flying buttresses and rusticated weatherboard patterning. So this is a screenshot of the node system that was used to create St Mary's. Very similarly to the diagrams before, the blue represents the basic shape of the church, the red is the subtractive components, and the green are the additive components. So with each of these nodes, the code that is used to create the geometry is housed inside it. When selected, each node will give a set of parameters that can be adjusted, which changes the geometry of the component. These parameters are references to the code housed within the node. What this results in is an adjustable reconstruction of St. Mary's Cathedral, where each parameter is able to be adjusted. This is something that is very important in digital architectural heritage, as you can never guarantee the accuracy of something that does not exist. So building this inaccuracy into the model is a very big advantage of procedural modeling. The next phase of this research was adapting the created system to create more designs. And so these were the component categories that we used to create the St. Mary's reconstruction. As we can see, if we compare to different designs such as Old St. Paul's and St. John's, there are very big differences between each of these designs. And so if I'm to create a procedural model that generates these types of buildings, more component categories will have to be added. And so then began the process of adjusting the system to create other designs. One of the first ones that I did was Old St. Paul's, as it was built only a year before St. Mary's Cathedral, and I thought it would share many similarities towards it. However, this was not the case, as many component categories had to be added. One thing that also had to be done is the adjustment of existing categories. And so things such as the sanctuary windows needed to be adjusted in order to fit with the new models. And so this was a process that went on for all of the component categories as they had to be refined. And so one of the interesting things that I found while reconstructing Old St. Paul's is the different types of geometry that differing architects use. And so Christian Toxwood designed the northern transept of Old St. Paul's as well as St. Mary's. He used the pointed arch. Frederick Thatcher was the original architect of Old St. Paul's, and he also did the southern transept. On both of these windows they used the drop arch. This minor detail is something I would not have noticed if I did not undertake this reconstruction process. Another church that I reconstructed was Christ Church in Taita. This was because it is one of the oldest churches in the Wellington region, and it is also a very small church. So I wanted to see if my procedural system could flex and create small designs as well as large designs. And so this also led me to the reconstruction of St. Peter's, as it was the opposite side of the spectrum, being a very large design. However, not too many component categories actually had to be added for that. And so now that I had a bigger library of components, I wanted to test if lost designs could be created as well. And so I undertook the reconstruction of the Wesleyan church that used to be on Manor Street. And so comparing this to the design of St. Peter's, it can be seen that they are very similar with a very large nave. The only real difference is the height of the tower and its position and what that does with the porch area. Another lost church that I chose to reconstruct was St. James's in Lower Hutt. And so the story behind this church is that the architect was not recorded, and so I wanted to see if I could figure this out. So looking at similar designs within the Wellington region, I found that the design of St. Patrick's in Masterton bore quite a resemblance. And so with the component categories that I already had, I could simply make a reconstruction of St. Patrick's as well as St. James's and compare the two. And what I found is that the transept windows are exactly the same and the overall layout is very similar. The only main difference, yet again, is the position of the tower and how this affects the feature window and entrance. And by quantifying these similarities, I hypothesized that they were created by the same architect, and upon further research, this was found to actually be the case. And so the next step of this research was to automate this process further. So this is the system that could create all these varying designs, and so it has changed quite a bit from the initial St. Mary's system. Much like in the previous system, each of these nodes corresponds to a component, and each of these components has parameters that are able to be adjusted. But selecting each of these nodes and adjusting the parameters individually was very tedious, and so in order to make a preset system, I collated all of these parameters into a master switch node. And so essentially, all of these designs are merely a different organization of 250 numbers or parameters. And not only can this system create real-life examples, it can also create designs in between. And so by adjusting these parameters, hybrid designs can be created. However, the adjustment of some components would result in the exact same change in other components. For example, the height of a buttress would be determined by the height of the component it is connected to. In the current system, this is not applied, and so I wanted to further automate this process and link parameters together. And so the way I achieved this was to engineer the resulting value of these parameters to be able to be switched from a user-entered value to a predetermined value that links components together and is based off of the data that has been collected throughout the research. And so this is where rules are created. And so what this allowed me to do was to have a preset system where real-life designs could be created, and then with the switch activated, randomly generated, fully procedural hybrid churches can be created. This was achieved through a process of linking and automating parameters. For example, the buttress spacing was a predetermined value defined by the length of the nave and the amount of buttresses. Other values, such as the actual length of the nave, were defined by the highest and the lowest values present in the case study group. And so through this refinement process, these outputs were generated, and so the goal of it was to simply create outputs that seemed somewhat realistic, however, to actually mimic the style in all its complexities would take a much larger refinement effort and research into the more subtle inherent rules. So in summary, this research provides a methodology for the investigation of pseudo-formalized rules within an undefined style of architectural heritage. Although this research did not come to a conclusive definition of the architectural style explored, with further refinement and linking of parameters, this could be achieved. Thank you.